Good day everybody. Ever wondered why insects can walk on water but humans can't? Over here, we have a video of a water strider. Let's check it out. Over here, we have a video of a human walking on water, which doesn't really go very well. Ooh, that didn't go well. Let's check out the structure of water to find out why that happens. Water is a very polar molecule. So, let's see. Water forms 4 hydrogen bonds. When water is in the medium, it can form those 4 hydrogen bonds anywhere around it. It can be up and down or sideways. But when on the surface of water, water is constrained because there's no water above it. The 4 hydrogen bonds can only be formed adjacent to the surface. Now this creates a lot of tension between those hydrogen bonds, also known as surface tension in this case. When the water strider walks on water, the gravitational pull on the water strider is less than the surface tension of water, and therefore it can never penetrate and always stays on the surface of water. But in case of humans, that's not the case. The gravitational potential on the water strider is less than the surface tension of water, and that's why it never penetrates the surface tension and hence can just simply walk on water. In case of humans, that's not the case. In case of a water strider whose mass is 400 milligrams, the gravitational pull on it would be 3.92 millinewtons. Now to find out how much surface area it requires to float on water, we simply divide this number by the surface tension of water, which is 0.073 newtons per meter square. That gives us the number 0.0053 meter square. That is the surface area required by a water strider to float on water. Now, a water strider is only 1 centimeter big. Having this kind of surface area on its feet is not really possible, but it can still float on water. Why is that? A water strider has millions of microscopic hair on its feet. This increases the contact surface area by a significant number, and hence it can float on water. In case of humans, that's not the case. An average human weighs about 65.5 kilograms, and therefore his weight would be 641.9 newtons, and the corresponding surface area would be about 8,793 meters square. This is about 80% of a soccer field. That's huge. The only other way humans can walk on water is if they have microscopic hair like the water strider. Imagine Spider-Man. Now, we all cannot be Spider-Man, can we? But we are forgetting the very important part in this entire discussion. When we considered the surface tension, we took the surface tension of distilled water, which is very pure. Unfortunately, on Earth, we do not have anything known as pure water. More than 75% of the water we have is salt water in the oceans. Let's see what happens when you have salt water instead of distilled water. Interesting. Wonder why that happens? When you dissolve sodium chloride in water, it increases the charge density of water. Now, they are more charged per volume than earlier. This means that the intermolecular forces which are responsible for the surface tension would be a lot higher in this case, and thus the surface tension would increase. Now we need less surface area. Think about it.